In the modern tech stack, cloud is the default setting. We spin up instances on AWS or GCP without a second thought, trading efficiency for convenience. But for high-throughput applications, databases, real-time analytics, or AI inference, this convenience comes with a hidden tax. I've seen companies spend an extra $100,000 a year just to fight the performance jitter of virtualized environments. They keep throwing bigger instances at the problem, not realizing that the bottleneck isn't the size of the box, but the abstraction layer itself. Today, we're looking at why the cloud-first mantra can lead to a massive performance mistake, and when it's time to go back to the metal.
To understand the performance gap, we have to look at the hypervisor. In a cloud environment, your application doesn't talk to the hardware. It talks to a virtual machine, which talks to a hypervisor, which finally talks to the physical CPU and RAM. This abstraction layer introduces latency. Every I/O request, every memory access must be translated. While modern Nitro cards and hardware-assisted virtualization have reduced this gap, it's still there. For most web apps, it's unnoticeable. But for a database doing 50,000 writes per second, that micro overhead compounds into a massive P99 latency spike. You're paying for hardware that you can only access through a middleman. Then there's the noisy neighbor. Cloud providers over-provision their hardware. Your VM might share a physical CPU core with 3 other customers. If their traffic spikes, your performance drops. This is called steal time. Even with dedicated instances, you're often sharing the underlying network backplane or NVMe storage controllers. On bare metal, you own the entire bus. There's no one else to fight for L3 cache or memory bandwidth. This predictability is why high-frequency trading and large-scale gaming backends almost exclusively use bare metal. They aren't just looking for speed, they're looking for consistency. In the cloud, your P99 is at the mercy of whoever else is on the rock. Bare metal removes the middleman. Your OS runs directly on the silicon. This means you get full access to hardware features like AVX 512 instructions for AI workloads, or direct NVMe pass-through without virtual driver overhead. You can tune the kernel specifically for your workload, adjusting interrupt handling, memory huge pages, or network stack buffers. This level of control is impossible in a managed cloud environment. When you control the hardware, you eliminate the variance. One server on bare metal can often outperform 3 or 4 virtualized instances of equivalent specs, simply because it's not wasting cycles on management and translation layers.
Let's look at the numbers. In a recent benchmark for a high-performance database, a top-tier cloud instance yielded about 12,000 IOPS with a P99 latency of 45 milliseconds. A comparable bare metal server, it hit 85,000 IOPS with a P99 of just 4 milliseconds. That's a 7x throughput increase and a 10x reduction in tail latency. To get that same 85,000 IOPS in the cloud, you would need to cluster at least 7 instances, adding massive complexity and cost. By switching to just 2 bare metal nodes for redundancy, the company saved over $8,500 per month. That's over $100,000 a year, while actually improving the user experience.
So, should you move everything to bare metal? No. Cloud is still unbeatable for elastic workloads, like a web front end that needs to scale from 2 to 200 instances during a sale. But for your core state, your primary databases, your message brokers, and your heavy-duty data processors, bare metal is often the superior choice. If your monthly cloud bill for a single service is crossing $2,000 and the workload is predictable, you are likely overpaying for underperforming hardware. The $100,000 mistake isn't using the cloud. It's using the cloud for things that require the raw efficiency of physical hardware.